So what we have is our two wires. We have one current going north, one current going south. One's 5 amps, one's 10 amps. And then we have all these 2 centimeter distances. We want to find the B field at A, B, and C. We're looking for the magnetic field here, here, and here. Okay, so let's just do it for A first. At location A. So what you're going to do is individually for each wire, you're going to find the magnetic field at each of those locations. So we're going to take wire 1, we're going to do our right hand rule. Okay, so my thumb follows the current. When my finger curls around, I'm going into the page at that location. So A is going to have an into current. So we could draw that B1 is into. Okay, we could draw that as an X, right? At that location, B is going into. So let's go ahead and calculate the value of that. So we're just going to use our equation we just learned, mu naught I over 2 pi r, where mu naught is 4 pi times 10 to the negative 7th. I is the current through wire 1, which was 5, divided by 2 pi, and the distance away from that is 2 centimeters, so we'll put 0.02. Okay, do the math on that. Looks like you're getting 5. 10 to the negative 5th Tesla, and we already determined the direction earlier. We said it was into. Okay, we're just going to do the same thing for both wires. So we're going to do B2 also. Okay, let's first of all figure out the direction of B2. So my thumb follows it down this way. When my fingers curl, notice that they're curling into also. So the B field is going to be into. B2 is also going to be into at that location. So you have two B's going into. So conceptually, if they're both going in the same direction, what are you going to do at the end? Add them up, right? They're both going in the same direction, so you're going to add them up. So B2, now if I was giving you weird numbers, you want to just go ahead and calculate this again. Mu naught I over 2 pi r. Now I did give you nice numbers. The distance is the same, but the current is doubled. Therefore, what should happen to the B field? It should be doubled, right? So, you could plug in the numbers if you wanted to. I'm just going to say it's 2. It should be 2 times B1. So this should be 10 times 10 to the negative 5th. This one was also into. So now if I ask you what's the B at location A, you would just add them up because they're both in the same direction. Into, you're going to add them up. You get 15 times 10 to the negative 5th Tesla into. That would be our answer. So let's do B. So this was location A. Let's do location B. So again, wire number 1 is going to create a magnetic field. When I curl around, okay, I'm coming out of. So when I curl around, I'm coming out of. So over here, my B1 is coming out. You could draw that with the circle. So notice B1, because the numbers are all the same, this is going to give us the exact same number as before. The distance is still the same. Remember, in a full circle all the way around, it's going to have the same field. The only difference is the direction now is going to be out. So B1 should be 5 times 10 to the negative 5th Tesla coming out. B2, we do have to figure out the direction for B2. So our thumb comes down this time. When we curl, At that location, it's also going into. So B2 is also going into over here. Okay. And then this one's not going to be the same. So if I gave you weird numbers, you'd go ahead and calculate it out, use mu naught I over 2 pi r. But I gave you nice numbers, right? Because notice, right here we were 2 centimeters away. How far are we now? 6 centimeters, which means we are 3 times farther. So if we're 3 times farther away, what should be true of the magnetic field? 3 times smaller, or 1/3. So the answer should be 1/3 of whatever we got before. And again, if they were weird numbers, you'd just want to go ahead and calculate it. But in this case, we can just say it's 10/3. And we just determined that was into. So notice these are in opposite directions, which means what's going to happen? Okay, they're going to be subtracting each other, right? This is out, this is in, subtract the 2. So if B at location B should be 5 times 10 to the negative 5th minus 3.33 times 10 to the negative 5th gives us a net of 1.67 times 10 to the negative 5th out. Okay, notice how much weaker we are when we're on outside versus when we're inside. Okay, so much weaker. Alright, so letter C, you're going to do likewise. I'm not going to do all the math on this, but what you should notice is since everything's all the same, all the distances are the same, everything's going to turn out the same, and you're going to actually get BC, you're going to get the same answer that we just got, and the same direction coming out.